Hi everybody, welcome to lesson 2 of our equations, linear equations unit. So today we're going to be looking at, we're going to continue to look at the equation of a line in the form of y equals mx plus b. And remember again that the m here is the slope, and the b here is the y-intercept value. And again, remember what your x and your y value, well, they just represent your coordinates, or how we used to say the x is usually your input and your y is usually the output. So those coordinates can be, you can have any set of coordinates, but the things that stay the same are the slope and the y-intercept. Okay, you can a line passes through many coordinates. Okay, let's get on with it here. So, okay, so let's just look at example number 1 here. It says, write the equation of a line passing through the point 0, 2 with a slope of 5/2. So I'm going to first write the general form, which is y equals mx plus b. And then I'm just going to go ahead and fill in my m and my b. So y equals, well, my m, that's the slope, so 5/2. And my b is the y-intercept, and this point here is the y-intercept because it is on the y-axis. So it's going to be 2. Okay, so that's just looking at it from a point and a slope. Let's see if we can do the same thing while looking at the equation in example number 2, or rather a graph. Okay, so line number 1, this one here, so I'm going to call it y1 because we have 2 lines, y1, and I'm going to call this one y2 here. So y1, and again, it's going to be mx plus b. And again, so I just want to get the slope here, y1. And how do I get the slope? Well, we remember that from last unit. You can get your rise over run here. I first need to get 2 points so I can calculate the rise over run. And I think I'm going to just get right there and right there. Again, you can be any 2 points because the slope is going to be the same for all along the line. So let's go rise over run. Well, it's a rise over of 1, 1, 2, 3. So that's 1/3. So 1/3 x, and then my y-intercept value. The y-intercept value is going to be right over here, and that's -4. So let me go ahead and input that in here. So it's going to be, let me change this to a -4. Okay. And there you go. Okay, equation number 2, y2 here, that's this line. It looks like it's going to have a negative slope because it's falling from left to right. And again, I'm going to look at my slope first. Let me pick any 2 points. Of course, try to pick points that are on the lattice points. You don't want to pick this point that goes halfway between the coordinates there. So you want to make sure you get integer coordinates. So let's go ahead and let's go down 1, 2, 3, and over 2. So it's going to be -2/3 x, and then let's go ahead and find my y-intercept, which is right there, plus 2. All right. So as long as you have the slope and the y-intercept, you can get your equation of the line, which is, again, this type of, we're going to see a few equations this unit. This type of equation is called it's called the slope-intercept form, because we're given the slope and the y-intercept. Okay, determine the equation of a line of the following lines. Okay, so determine the equation of the following lines. So we want a line that's parallel to this line and with the same intercept as this other line here. So we have, we want to come up with our own line. Our line is going to be y equals mx mx plus b. All right, we're going to call that our line. We'll call it line 1 here. So it's parallel. So our line here is parallel to this other line. Call this one line 2, and has the same y-intercept as this third line over here. Y equals 6x minus 7. Okay, so let's go ahead and get the. Remember, parallel lines have the same slope. That's a key word there. Parallel lines have the same slope. So I'm going to borrow this slope over here for our line, 1 over 3 x, and I'm going to borrow the y-intercept from this third line over here. So minus 7. So we're kind of piecing together information from other lines to come up with our own line. Okay, so that was that one. Let's go to B. So okay, let's come up with our line. Okay, I'll call it y equals mx plus b. We can call it y1 if you like. All right, so our line passes through the point 0, 9. And notice right away that 0, 9 is the y-intercept. That's really important to notice there. So that's the y-intercept because the x-coordinate is 0. And so right away we got our y-intercept. So I'm just going to go mx plus 9. Okay, but we still got to get our slope. So what's the other piece of information? Well, it says that our line is perpendicular to this third line here. Okay, and this line here goes through the points 2, negative 6 and negative 5, 0. So okay, so I gotta use some other information now to get the slope for our information. Well, I'm going to calculate the slope for this line, okay, and use that information to get my slope. So what is the slope of this line here, this third line that has these points? Well, let's go ahead and calculate it. So let's call this line 2. Okay, we'll call it line 2, and R is line 1 here. So the slope of line 2 is rise over run, or y2 minus y1 over x2 minus x1, the change in the y over the change in the x. Okay, so let's go ahead and plug my numbers in. I have 0 minus negative 6, so 0 plus 6, and negative 5 minus 7. Oh, excuse me, minus 2. Okay, and that comes out to be 6 over negative 7, so right there. Okay, well, if our line is perpendicular to this line over here, it means that our slope is going to be, remember, it has to be the negative reciprocal. So the negative reciprocal of that would be 7 over 6 x plus 9. All right, and if you go ahead and if you want to plug in these two lines into your calculator and graph them, okay, you will see that they're going to be parallel. All right, let's go ahead and do a few more examples. The diagram on the screen shows the display from a graphing calculator. The intercepts are integers. That's important. Okay. Determine the equation of the line shown. All right, so always start with your slope-intercept form. Y equals mx plus b. The slope is going to be, okay, be careful here because of the scale. Okay, so you gotta really remember how to read your, this is your window setting over here, and the x scale is 7 and the y scale is 5. So the y scale, this is 5, this is 10, so the y-intercept is 10. On the other hand, this is 7, 14, 21, 28, and so on. Okay, so I'm interested in this point over here to get my rise over run. Well, the rise over run here, okay, it's going to be 10 because I dropped 10 over, and then the run is going to be 28. And again, be careful to get your signs correct, as it is negative 10 over 28. And you always want to simplify that. So that's going to be divided both by 2 there. It's going to be negative 5 over 14 x plus 10. Okay. Let's do a couple more questions. Okay, what about horizontal and vertical lines? Horizontal and vertical lines are a little bit different. Remember the slope of horizontal lines is going to be 0, and the slope of vertical lines is going to be undefined. So say the slope and y-intercept of the horizontal line L1. So this is L1. So y equals mx plus b. Always start with that. Y equal, what is the slope? Well, the slope is, it's a horizontal line. So it's going to be 0. So 0 times x is just 0. So I'm just going to be left with b. Well, what's b? B is over here, the y-intercept, and that's 5. So it's just going to be y equals 5. And that kind of makes sense. Really, there is only, there's really no x-coordinates here. There are infinite amount of x-coordinates. The y-coordinate is always 5. Doesn't matter what the point is. This point here is going to be 1, 5. This point here is going to be 4, 5. So that kind of makes sense. Y equals 5 is just a horizontal line at y equals 5. Okay. Use the form y equals, oh well, I just did that. Oops, so I did 1 and 2 together here. All right. Move on to C. Predict the equation of horizontal line 2. Well, line 2 is going to be y equals whatever the y-coordinate is, -6. That's pretty simple, okay? All right, now things get a little tricky for vertical lines. The slope and the y-intercept of line 3, I'll do it in red here. Well, the slope is undefined. I can put a 0 with a line through it. And the y-intercept, there is no y-intercept. Okay, so we're in a little bit of trouble, and it says, why can't we not use the form y equals mx plus b to determine the equation? Well, because this here is undefined, and this also does not exist. So, we're in some trouble. So, but there is a solution, and the solution is actually x equals whatever the x-coordinate is, and the x-coordinate is going to be right there. The x-coordinate is going to be -3. So it's going to be x equals -3. And that it's kind of the opposite of this one, y equals -6, because again, x equals -3 means that every coordinate is going to go through -3. And if we look in the graph here, indeed, every coordinate here goes through -3. Okay, here's an interesting question. Predict the equation of the vertical line 3. Well, we just did that, okay. And it says, why can't we not use a graphing calculator to verify it? Because the reason is because your graphing calculator, let me pull it up here, only does, when you go into your y equals, okay, well, it's in terms of y. So y equals something, right? Well, this time we don't have a y. So your calculator cannot get it. And the simple answer is vertical lines are not functions, because they fail the vertical line test. And therefore, because they're not functions, you cannot put them into your calculator. That doesn't mean we don't have an equation for them. It just means that they're not functions. So again, remember what a function is. For every input, there can only be one output. In this case, my input is always -3, but I have many outputs. As a matter of fact, I have infinite number of outputs, and that clearly breaks the rule of a function. All right, so here's the general rule. The equation y equals k, where k is just any number, represents a horizontal line through that point, k. So if it's y equals 7, we're going to get a line that goes through point 1, 2, 3, 4, 5, 6, 7. We're going to get a horizontal line that goes through 7. On the other hand, when it's x equals k, we're going to get a vertical line through k. So if it's x equals -7, let me not use 7, let me use 8, okay? It's going to be 1, 2, 3, 4, 5, 6, 7, 8. That's -8. It's going to be a vertical line through -8. Okay, thanks for watching, guys, and we'll actually no, there's one more question here, so stay with me here for this last one. Determine the equation of a line through the point -2, 8, and it's parallel to the y-axis. So here we can get this because we know our rules for horizontal and vertical lines. So determine the equation of a line through the point -2 and 8 and parallel to the y-axis. Well, let's do a diagram here. So if I have my diagram here, okay, and the point goes -2 and 8, so -2 is 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. I have my point right here, and it's parallel to the y-axis. That means that my graph looks something like that. And what's the equation going to be? Well, the equation is going to be x equals whatever the coordinate is that the line goes through, which is -2. In this case, parallel to the x-axis, well, if it goes through this point, it's parallel to the x-axis. It's going to be a horizontal line because that's parallel to the x-axis. And then it's going to be y equals 8 because it goes through all coordinates of 8. Okay, now we're done. See you guys next time. Thanks for watching.